the skies.
You can check out the latest news from NEOCC and their risk list by going to the website neo.ssa.esa.int. I'm Kelsey Brennan-Wessels for ESA Web TV. Thanks for watching.
Hera is going to show us things no one's ever seen before. This ESA mission will be humanity's first ever spacecraft to visit a double asteroid, Didymos. This asteroid is typical of the thousands that pose an impact risk to our planet. Imagine a mountain in the sky with another rock about the size of the Great Pyramid swinging around it. That's Didymos. And just the seemingly tiny moon would be big enough to destroy a city if it were to collide with the Earth. But we're going to find out if it's possible to deflect it. This is going to be really, really hard. Aiming at a 160-meter wide target across millions of kilometers of void. Could we stop an asteroid hitting planet Earth? The dinosaurs couldn't, but we humans have the benefit of knowledge and science on our side. Hera is led by a multinational team of scientists and engineers, humanity's makers and doers. Right now, all we have is many years of research and theories, but Hera will revolutionize our understanding of asteroids and how to protect ourselves from them. First, NASA will slam its DART spacecraft into the smaller asteroid at more than 6 kilometers a second. Then ESA comes in. Hera will map the impact crater left by DART and measure the asteroid's mass. Knowing this mass is key to determining what's inside and knowing for certain whether we would be able to deflect it. Next come our briefcase-sized CubeSats. If you think of Hera like an aeroplane, then CubeSats will operate more like drones, able to take more risks, flying closer to the asteroid, carrying state-of-the-art science instruments, eventually touching down. The scale of this experiment is huge. One day these results could be crucial for saving our planet. Hera's up-close observations after DART's impact will help prove whether asteroids can be deflected, prove whether this is an effective planetary defense technique, so that if an asteroid ever poses a real threat to Earth, we'll be ready.
When humans finally fly to an asteroid, they will need the same skills that they do now. They must be able to use technology to perform science and exploration. However, there is something more. They're going to need some new technology. Initially, we're going to have to be able to find this asteroid, so very precise guidance and navigation. And then we're going to have to park close to an asteroid without hitting it, and that's going to be something that needs to be developed. And thirdly, once the humans need to go on the surface of the asteroid, they're going to need new spacesuits capable of anchoring themselves onto the surface, because such a small gravitational field is going to be very, very hard to explore. So some of the technologies that I just talked about are partially available today. We do have spacesuits, but we must be developing new ones in order to be able to perform the kind of tasks that are going to be necessary for exploration and exploitation of an asteroid. And for the spacecraft, we already have navigation system. We already have, for example, our spacecraft to the International Space Station. But in the future, this new spacecraft will have to be able to do that when connected to a completely unexplored little world like an asteroid. Space is an inherently risky environment, and obviously flying to an asteroid is going to present all the same risks that you have flying in space. And everything that is in the unknown is always an increase in the risk. Today, we are preparing for these missions using Analog's environment. One of these environments is called NEEMO, the NASA Extreme Environment Mission Operations. It's where we stay underwater in a small environment for 2 weeks in a habitat that's called Aquarius, about 20 meters underwater. When we are in this environment and we stay there for the whole time underwater, we perform the same tasks that we would perform on an asteroid, and we take advantage of the neutral buoyancy of being underwater to simulate the microgravity environment that we would find on an asteroid. Nowadays, when we perform our missions on the International Space Station, it's a very known environment that was designed to be used with handholds and specific places where we can anchor ourselves in order to operate. When we go to an asteroid, we won't have any of those tools. We are going to bring our own and to install them in order to be able to explore and navigate around the asteroid. When we land one day on that asteroid, the lucky person is going to feel something that has never been done before. He's going to be standing on a very, very tiny world with a very small horizon, rotating in the universe. It's going to feel that the whole universe is rotating about you. And I think that that's part of the beauty of it, that we just don't know what it's going to feel like.
Welcome back to a new episode of Earth from Space. The Gulf of Martaban, an arm of the Andaman Sea located in southern Myanmar, is featured in this false color image captured by Copernicus Sentinel-2. The image has been processed in a way that included the near-infrared channel, which makes vegetation appear bright red. The Gulf of Martaban is considered a unique estuarine mudflat environment that is home to a great variety of flora and fauna. Fed by sediment and nutrients from 3 major rivers, the Gulf supports a number of species, including marine fish, 150,000 migratory birds, as well as supporting the livelihood of tens of thousands of people. The Sittang River originates near Mandalay in Myanmar and flows southward for around 420 kilometers before emptying into the Gulf. A notable characteristic of the Gulf is that it has a tide-dominated coastline, with tidal ranges between 6 and 7 meters. The mouth of the Gulf, which is approximately 100 kilometers wide, narrows into a funnel-shaped bay to produce a powerful tidal bore phenomenon that can reach heights of over a meter in the upper estuary. As a result, the tidal mudfloods of the Gulf are among the largest in the world. The distinct rectangular shape is part of the Moyanji Wetland Wildlife Sanctuary, a designated